Effects on the carbon cycle. Increased emissions of airborne nitrogen have led to an increase in the depositing of nitrogen on land and in the oceans. Thanks to the fertilizer effects of nitrogen in stimulating plant growth, this depositing may be acting to influence the atmosphere indirectly by altering the global carbon cycle. Over much of Earth's surface, the lushness of plant growth and the accumulation of standing stocks of plant material historically have been limited by scanty nitrogen supplies, particularly in temperate and boreal regions. Human activity has substantially increased the amount of nitrogen over much of this area, which raises important questions. How much extra plant growth has been caused by human-generated nitrogen additions? As a result, how much extra carbon has been stored in land ecosystems rather than contributing to the rising concentrations of carbon dioxide in the atmosphere? Answers to these questions could help explain the imbalance in the carbon cycle that has come to be known as the missing sink. The known emissions of carbon dioxide from human activities such as fossil fuel burning and deforestation has resulted in excessive amounts of carbon dioxide accumulating in the atmosphere each year. Fertilizer use. Plants contain valuable nitrogen. When we harvest and eat plants, this valuable nitrogen often does not get returned to the ecosystem and thus there is a break in the nitrogen cycle. A break in the nitrogen cycle will result in soil lacking nitrogen. Often, in our attempt to restore this nitrogen, we may cause other problems in the ecosystem by interfering in an otherwise natural cycle. The greatest human-driven increases in global nitrogen supplies are linked to activities intended to boost food production. Modern intensive agriculture requires large quantities of nitrogen fertilizer. Fertilizers are materials that restore or add nutrients to soil. They are used to increase production from the land and may be natural, manure, or synthetic, chemical. Humanity, in turn, requires intensive agriculture to support a growing population that is projected to double by the end of the next century. Consequently, the production and application of nitrogen fertilizer has grown exponentially, and the highest rates of application are now found in some developing countries with the highest rates of population growth. Fertilizers need to be used sparingly, and curtailing this growth in nitrogen fertilizer production will be a difficult challenge. Nevertheless, there are ways to slow the growth of fertilizer use and also to reduce the mobility, and hence the regional and global impacts, of the nitrogen that is applied to fields. What is pH? Acidic and basic are two extremes that describe chemicals, just like hot and cold are two extremes that describe temperature. Mixing acids and bases can cancel out their extreme effects, much like mixing hot and cold water can even out the water temperature. A substance that is neither acidic nor basic is neutral. The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14. A pH of 7 is neutral. A pH less than 7 is acidic, and a pH greater than 7 is basic. Each whole pH value below 7 is 10 times more acidic than the next higher value. For example, a pH of 4 is 10 times more acidic than a pH of 5 and 100 times, 10 times 10, more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more alkaline, another way to say basic, than the next lower whole value. For example, a pH of 10 is 10 times more alkaline than a pH of 9. Pure water is neutral, with a pH of 7.0. When chemicals are mixed with water, the mixture can become either acidic or basic. Vinegar and lemon juice are acidic substances, while laundry detergents and ammonia are basic. Chemicals that are very basic or very acidic are called reactive. These chemicals can cause severe burns. Automobile battery acid is an acidic chemical that is reactive. Automobile batteries contain a stronger form of some of the same acid that is in acid rain. Household drain cleaners often contain lye, a very alkaline chemical that is reactive. Changing the pH of soil. In soil, bacteria change the nitrogen found in fertilizers into nitrates, which are then used by plants. If there are large amounts of nitrates, this may result in large amounts of nitric acid. Large amounts of nitric acid in the soil results in a decrease in the pH of the soil. Changes in the acid content of the soil affects all living organisms such as worms and bacteria, which require a certain pH in which to live. As fertilizers are applied to soils over the years, the pH of the soil will change drastically. Depending on the soil and the other chemicals in the fertilizer, a typical yearly application of nitrogen fertilizer over a 10-year period can result in a soil that is 10 times more acidic. Remember, an increase 10 times means a drop in pH of 1. A drop in pH such as this can have a devastating effect on the food that gets produced in this soil. For example, most grassland soils in Canada's prairies have a pH of 7, and if the pH were to drop to 6, then certain plants such as barley would not grow as well. Environmental problems. Algal blooms. The accumulation of nitrogen and phosphate fertilizers can result in algal blooms in lakes and ponds during spring runoff. As spring runoff carries rotting plant material and fertilizer-rich soil into streams and lakes, the nutrients provide an abundance of food for algae living in the water. If temperatures are warm, this results in a large growth in algae known as an algal bloom. When the algae die, bacteria use oxygen from the water to decompose them, which results in less oxygen for fish and other animals. As a result, the population of fish and other animals will begin to decrease. Dying fish and other animals will then result in even less oxygen as bacteria use up this oxygen, breaking down their dead bodies. Human health and the nitrate problem. Nitrates are a widespread contaminant of ground and surface waters worldwide. Nitrate is a potential human health threat, especially to infants, causing the condition called blue baby syndrome. Nitrate is converted in the gut to nitrite, which then combines with hemoglobin in the blood, decreasing the ability of the blood to carry oxygen. Infants are at more risk of receiving this condition than older children or adults. Deaths are rare, but can affect development. High levels of nitrate in the body may also cause other health problems such as cancer. In addition, high nitrate levels in water and feed lead to increased stillbirth, low birth weight, and slow weight gain in livestock. Nitrate concentration is monitored in municipal water supplies worldwide, and in foodstuffs, to prevent exposure of populations to harmful or toxic levels. Organic farming. As people have become more aware of the connection between their food choices and their health as well as the health of the environment, organic food has become one of the fastest growing trends in the food industry. Many supermarkets have an organic food section whereby people are prepared to spend more on such food items for the sake of their own health and the health of the environment. Organic farmers use no chemical herbicides or fumigants, use only natural or other organically approved insecticides, provide a safer working environment for field workers, grow strong, healthy plants which are more resistant to disease, save water by building healthy soils which retain moisture, conserve resources by using composted natural waste products to feed and balance the soil, naturally help keep our air, soil and water as well as our food supply free of toxic chemicals, work with nature to replenish Earth's soil for a sustainable future. Organic versus inorganic fertilizers. There has been much controversy over organic versus inorganic fertilizers. It is important to realize that plants do not recognize the difference between organic and inorganic fertilizers. Their tiny root hairs can absorb only nutrients that have been broken down into inorganic, water-soluble forms. It makes no difference to your tomato plant if the atom of nitrogen it is absorbing has come from a compost pile or a fertilizer factory. There are, however, advantages and disadvantages to each form of fertilizer, organic and inorganic. Organic fertilizer advantages. Organic nutrients include such things as cow, sheep, poultry and horse manure. One should avoid using pig, dog or cat feces because of the problems involved with internal parasitic worms which may be transferred to humans. Bone meal, blood meal, compost, and green manures will also provide nutrients for your plants. There is less danger of over-fertilization by adding decomposed organic material to a garden. It provides a slow release of nutrients as microorganisms in the soil break the organic material down into an inorganic, water-soluble form which the plants can use. The addition of organic material improves soil structure or workability immensely. It also vastly improves the water-holding capacities of sandy soils. Disadvantages. If there is an immediate need for nutrients, organic fertilizer cannot supply them in a hurry. Information on the amount of nutrients and the exact elements in an organic fertilizer such as manure is not readily available to the home gardener. In contrast, when you apply manufactured inorganic fertilizer, you know the kinds and amounts of the elements it contains, and this allows you to be more precise in meeting a plant's nutritional needs. The possibility of nitrogen depletion is another drawback of organic fertilizers. Because of complex bacterial action, the addition of a large amount of organic material can cause a temporary nitrogen depletion in the soil and therefore in the plants. Inorganic commercial fertilizer advantages. The primary advantage of using packaged commercial fertilizer is that nutrients are immediately available to the plants. As well, the exact amounts of a given element can be calculated and given to plants. Disadvantages. Commercial fertilizer, especially nitrogen, is easily washed below the level of the plant's root system through the leaching of rain or irrigation. An application which is too heavy or too close to the roots of the plants may cause burning. As well, overly heavy applications of commercial fertilizers can build up toxic concentrations of salts in the soil, thus creating chemical imbalances. If organic materials are readily available and cheap, the expense of the commercial fertilizer should also be considered. Whether a gardener chooses to use organic, inorganic or a combination of both types of fertilizers, it's important to follow the guidelines regarding timing of application, placement of the fertilizer, and the proper amount of fertilizer to be applied.